Hi friends, welcome to Recruitment Vardi. Now ఈరోజు మనం బేసిక్ ఎలక్ట్రిసిటీ గురించి తెలుసుకుందాం. దాని మీద క్వశ్చన్స్ అన్ని నేర్చుకుందాం. సో బేసిక్ ఎలక్ట్రిసిటీ, సో ఎలక్ట్రికల్ సంబంధించిన ప్రతి స్టూడెంట్కి ఇవన్నీ క్వశ్చన్స్ అవసరం ఉంటాయి. ఎలక్ట్రికల్ ఐటీఐ కానీ, డిప్లొమా కానీ, బీటెక్ కానీ, ఈవెన్ ద కాంపిటేటివ్ ఎగ్జామ్స్ ఎన్ని రాసిన వాళ్ళందరికీ ఈ క్వశ్చన్స్ అనేది ఖచ్చితంగా యూజ్ అవుతాయి. అండ్ కమింగ్ టు ద ఫస్ట్ క్వశ్చన్, హౌ మెనీ నెంబర్ ఆఫ్ ఎలక్ట్రాన్స్ ఇన్ ఏ కాపర్ ఆటమ్? సో కాపర్ ఆటమ్ మనకు తెలుసు, ఆటమ్ అంటే స్మాలెస్ట్ పార్టికల్ అని. సో ఆటంలో ఏముంటాయి? ఎలక్ట్రాన్స్, ప్రోటాన్స్, న్యూట్రాన్స్ అని 3 ఉంటాయి. సో నార్మల్గా అయితే 29 ప్రోటాన్స్, 35 న్యూట్రాన్స్ and 29 electrons ఉంటాయి. సో ఆన్సర్ ఇస్ ఏ 29 electrons. And next, how many number of electrons will move in 1 second for 1 ampere current through a cross section of a conductor? సో మనకున్న కండక్టర్ క్రాస్ సెక్షన్ ఏరియాలో how many electrons will move in 1 second? 1 second ఫర్ ఆంపియర్, 1 ఆంపియర్ కరెంట్ ఫ్లో అవుతున్నప్పుడు ఎన్ని ఎలక్ట్రాన్స్ మూవ్ అవుతాయి ఇన్ 1 సెకండ్ అనేది క్వశ్చన్. సో దీనికి ఆన్సర్ వచ్చేసి 6.24 ఇంటూ 10^18. సో ఈ క్వశ్చన్ డైరెక్ట్ ఆన్సర్. సో ఎక్కడైనా కానీ మనం ఎలక్ట్రాన్స్ ఫ్లో, కరెంట్ అంటే ఫ్లో ఆఫ్ ఎలక్ట్రాన్స్. సో ఫ్లో ఆఫ్ ఎలక్ట్రాన్స్ అనేది జరిగితేనే మనకు కరెంట్ అనేది వస్తుంది. సో ఈ ఎలక్ట్రాన్స్ మూవ్మెంట్ అనేది జరగాలంటే ఎలక్ట్రాన్స్ మూవ్ అవ్వాలి. అలాంటివి 1 ఆంపియర్ కరెంట్ రావడానికి ఎన్ని మూవ్ అవుతాయి అనేది క్వశ్చన్ ఇక్కడ. సో 6.24 ఇంటూ 10^18. అండ్ థర్డ్ వన్ ఇస్ 1 joule per second is answer is watt. 1 watt. 1 watt equal to 1 joule per second. And next one, practical SI unit of heat is expressed in unit of heat. Unit of heat is expressed in joule, అది SI unit. And next question is the unit of power. మనకు తెలుసు యూనిట్ ఆఫ్ పవర్ అంటే V into I. ఏంటి సో మనం వాట్ అనుకుంటాం. ఇక్కడ కిలో వోల్ట్ ఉంది, ఇక్కడ వాట్ అవర్ ఉంది. ఇవన్నీ కాదు, ఓన్లీ కిలో వాట్ ఇస్ ఏ పవర్ ఆన్సర్. వాట్ ఈస్ ద వాల్యూ ఆఫ్ రెసిస్టివిటీ ఆఫ్ కాపర్ కండక్టర్? సో మనం ఇందాక కాపర్ ఎలక్ట్రాన్ చూస్తాం. సో కాపర్ కండక్టర్ రెసిస్టివిటీ ఎంత? రెసిస్టివిటీ వాల్యూ ఆఫ్ రెసిస్టివిటీ ఎంత? సో ఇక్కడ ఆన్సర్ వచ్చేసి 1.72 మైక్రో హౌస్ పర్ సెంటీమీటర్ క్యూబ్. అండ్ వాట్ ఇస్ ద యూనిట్ ఆఫ్ స్పెసిఫిక్ రెసిస్టెన్స్? స్పెసిఫిక్ రెసిస్టెన్స్ మీకు తెలిసే ఉంటుంది. R is equal to rho L by A. సో మీకు ఈ ఈక్వేషన్ తెలిసి ఉంటుంది, ఆ ఈక్వేషన్లో ఉంటుంది ఇది. సో R equal to rho L by A. సో దీని ఆన్సర్ వచ్చేసి మైక్రో హోమ్ పర్ సెంటీమీటర్ క్యూబ్. నెక్స్ట్ వచ్చేసి SI యూనిట్ ఆఫ్ స్పెసిఫిక్ రెసిస్టెన్స్. దట్ ఈస్ హోమ్ మీటర్. స్పెసిఫిక్ రెసిస్టెన్స్ అండ్ హోమ్ మీటర్. యూనిట్ ఆఫ్ స్పెసిఫిక్ రెసిస్టెన్స్, SI యూనిట్ ఆఫ్ స్పెసిఫిక్ రెసిస్టెన్స్. నెక్స్ట్ క్వశ్చన్స్ అన్ని పార్ట్లో వద్దాం. థ్యాంక్ యూ. హాయ్ ఫ్రెండ్స్, Welcome to Recruitment Vardi. Now we are studying second class of basic electricity. So last class lo manam basic electricity lo konni questions తీసుకున్నాం, and today we are discussing the other questions. And దీంట్లో which electrical device is the examples of medium resistance? So మనకు తెలుసు రెసిస్టెన్స్ 3 types గా డివైడ్ అయితే అని, లో రెసిస్టెన్స్, మీడియం రెసిస్టెన్స్, హై రెసిస్టెన్స్. అండ్ లో రెసిస్టెన్స్ వచ్చేసి 1 ohm నుండి 1 ohm కంటే తక్కువ ఉంటాయి. మీడియం రెసిస్టెన్స్ అంటే 1 ohm కంటే ఎక్కువ ఉంటాయి. హై రెసిస్టెన్స్ అంటే అబోవ్ 100 kilo ohms అంటే హై రెసిస్టెన్స్ అంటే. సో దీంట్లో విచ్ ఎలక్ట్రికల్ డివైస్, సెంటర్ రెసిస్టెన్స్, హీటర్ రెసిస్టెన్స్, కాంటాక్ట్ రెసిస్టెన్స్. సో ఇందులో సెంటర్ రెసిస్టెన్స్ వచ్చేసి లో రెసిస్టెన్స్, హీటర్ రెసిస్టెన్స్ మీడియం రెసిస్టెన్స్, కాంటాక్ట్ రెసిస్టెన్స్ అనేది లో రెసిస్టెన్స్, ఆర్మేచర్ వైండింగ్ అనేది కూడా లో రెసిస్టెన్స్. సో ఇక్కడ మీడియం రెసిస్టెన్స్ కాబట్టి ఇక్కడ ఆన్సర్ బి. Next, what is the commercial unit of electrical energy? And ఈ ఆన్సర్ మనకు తెలిసిందే. కమర్షియల్ అంటే ఇప్పుడు మన ఇంట్లోకి యూజ్ చేస్తాం కదా యూనిట్ ఆఫ్ ఎలక్ట్రికల్ కరెంట్. సో అది. సో దీన్ని మనం ఈజీ చెప్పచ్చు. ఆన్సర్ ఇస్ డైరెక్ట్లీ ఆన్సర్ బి. Next, the increase in resistance per ohm per degree centigrade rise in temperature is positive temperature coefficient. So increasing resistance per ohm per degree centigrade is positive temperature resistance. Which are the material which material is having negative temperature coefficient? Negative temperature coefficient. So this answer is carbon. Carbon material has negative temperature coefficient, and both have tungsten, uranium, and nickel have positive temperature coefficient, and only carbon have negative temperature coefficient. And next question, which is the example of negative temperature coefficient substance? మీదనే which are the following having negative temperature coefficient? ఇక్కడ కూడా సేమ్ క్వశ్చన్, అండ్ ఇంట్లో మనకు తెలిసిన ఆన్సర్ ప్రకారం అయితే నిక్రోమ్ కాదు, అండ్ కాపర్, అల్యూమినియం, అండ్ ఆన్సర్ ఇస్ మైకా. Answer is mica. Next, the change in resistance per ohm per degree centigrade is temperature coefficient. ఇందాక చూసాం కదా, the change in resistance per ohm per degree centigrade is called temperature coefficient resistance. సో ఇట్లా అలా so the change in resistance per ohm per degree centigrade is called temperature coefficient of resistance. సో ఇలా చేంజ్ ఇన్ రెసిస్టెన్స్ పర్ హోమ్ పర్ డిగ్రీ సెంటిగ్రేడ్ జరిగినప్పుడు టెంపరేచర్ ఇంక్రీజ్ అయితే పాజిటివ్ టెంపరేచర్ కోఎఫిషియంట్, టెంపరేచర్ డిక్రీజ్ అయితే నెగిటివ్ టెంపరేచర్ కోఎఫిషియంట్. యాజ్ పర్ హోమ్స్ లా స్టేట్మెంట్ in the circuit current is directly proportional to voltage. Directly proportional to voltage and దీంట్లో temperature coefficient, which law states the relation between the current, voltage and resistance in a closed circuit is at a constant temperature. So constant temperature voltage current resistance relation తెలిపే లా ఏంటి అనేది ఇక్కడ క్వశ్చన్. ఆన్సర్ వచ్చేసి హోమ్స్ లా ఈక్వల్ టు V equal to I or at a constant temperature V is directly proportional to I. Our current is directly proportional to voltage. Next వచ్చేసి which law states that in each closed circuit the sum of all voltage drops is equal to 0. So answer is Kirchhoff first law. So Kirchhoff first law అనేది దాన్ని Kirchhoff కరెంట్ లా అని కూడా అంటారు, వోల్టేజ్ లా అంటారు. సో దీంట్లోనే all the voltage drops are equal to 0. So answer is B. Next, in any electrical network, the sum of the income currents at each junction is equal to the sum of outgoing currents. What is the name of law? That is Ohm's law ఏమో వీక్ లాస్ ఆఫ్ రెసిస్టెన్స్ ఏమో రెసిస్టెన్స్ ప్రాపర్టీస్ లాస్ తెలుస్తాయి. అండ్ ఆన్సర్ ఇస్ కిర్చాఫ్ సెకండ్ లా. సో ఇక్కడ కిర్చాఫ్ సంబంధించిన 2 లాస్, ఒకటేమో వోల్టేజ్కి రిలేటెడ్ ఉంటుంది, ఇంకోటేమో కరెంట్ రిలేటెడ్ ఉంటుంది. వోల్టేజ్ రిలేటెడ్ ఉన్నదేమో ఫస్ట్ లా, current related ఉన్నదేమో సెకండ్ లా. అండ్ which law states that the sum of the currents meeting at the junction is equal to 0. అండ్ ఇది కూడా Kirchhoff సెకండ్ లా, బికాస్ ఇక్కడ ఇందాక చెప్పాను కదా కరెంట్ రిలేటెడ్ లా ఇస్ సెకండ్ లా. when the current is passed through the conductor it gets shifted, that effect is called. కరెంట్ అనేది కరెంట్ పాస్ అయినప్పుడు కండక్టర్ అనేది హీట్ అవుతుంది. ఎందుకైతే ఆ ఎఫెక్ట్ ఏమంటారు, దట్ ఈస్ థర్మల్ ఎఫెక్ట్. అండ్ యాజ్ పర్ ఐఏ రూల్స్ caution notice shall be displayed on the electrical equipment lines depending upon the level of what type of caution is displayed on the equipment line operating 650 volts to 33 kV volts. And ఇక్కడ ఆల్రెడీ 33 kV volts. సో 33 kV volts అంటే అది మీడియం వోల్టేజ్ కాదు, సో ఇది హై వోల్టేజ్. సో అక్కడ ఏం రాలే, సెకండ్ ఆప్షన్ బి కాషన్ హై వోల్టేజ్. నెక్స్ట్ వచ్చేసి The conversion of energy which takes place in the thermal power station is థర్మల్ పవర్ స్టేషన్లో ఏం జరుగుతుంది? సో సోలార్ టు ఎలక్ట్రికల్ జరగదు, హైడ్రోజన్ టు ఎలక్ట్రికల్ జరుగుతుంది, లైట్ ఎనర్జీ టు ఎలక్ట్రికల్ ఎనర్జీ జరగదు. సో ఆన్సర్ ఈస్ ఏ, హీట్ ఎనర్జీ టు electrical energy. Which of the formula to is easy to find the power if the current and voltages are known values? So V equal to V into I. So current and voltage తెలిస్తే మనం పవర్ వాల్యూ క్యాలిక్యులేట్ చేసేది VI అంటే. The energy or energy in an electrical circuit is calculated by so energy is watt and W, it is given by W is equal to I square RT, that is power into time. Energy is equal to power into time, power is equal to V I square R. సో ఇది ఎలా అంటే P V into I ఉంది కదా, పవర్ ఈక్వల్ టు V into I. సో V ఈక్వల్ టు మనం యాక్స్ పర్ హోమ్స్లో V ఈక్వల్ టు I by R అని రాసుకోవచ్చు, దట్ ఈస్ I square R. నెక్స్ట్ వచ్చేసి మెథడ్ ఆఫ్ క్యాలిక్యులేటింగ్ ఎనర్జీ బై వోల్ట్మీటర్, అమ్మీటర్ అండ్ స్టాప్ వాచ్ ఈజ్ instead of 25 is a kilowatt hours, that is VIT 100 into 60. సో యాజ్ పర్ హవర్కి మనం కనుక్కోవాలి kilowatt hour, 1 kilometer is equal to V equal to voltage current time. Hello friends, welcome to Recruitment Vardi. This is third class of basic electricity. So question number 26. An appliance has a resistance of 100 ohms, takes 2 amperes. What is the power consumed by the appliance? So here ohms resistance given and current amperes given. What is the power consumed? It well as known as power consumed is VI, that is I R square. I means 100, R square means I square R. I square R, that is 400. Answer is 400 watt. And next question is, a 1000 watt heater is connected to a 240 volt AC supply, then the current drawn by the heater is. Answer is D, 4.166 amperes. So here 1000 watts is power, 240 volts is voltage, and 4.16 is current. So calculate both. So here we take VRMS value to have this value. The given Wheatstone bridge is balanced when P equal to 100 ohms, Q equal to 1 kilo ohms, S equal to 120 ohms. Calculate the value of unknown resistance. So in the Wheatstone bridge there are 3 resistance given. Finding the unknown value of unknown resistance. Answer is B, that is 1.2 kilo ohm. And next, what is the power input to an electric heater that draws 4 amperes at 240 volts supply source? Answer is, what is the power input? Power input at 4 amperes and 250 volts. So the answer is D, Next question, a 10 volts battery is connected to a 5 ohms resistor. Then the current flows through the resistor is 10 volts battery and 5 ohms resistor. Calculating the current. Answer is D, that is 2 amperes. V equal to IR, I equal to V by R. This is the formula to find out. And still here, from the given figure of dual supply, determine the current through the resistance. So determine the current through the resistance, that is between the 2 points, what is the resistance? And the answer is B, 1 ampere. Here you know the resistance is given, and here we need to find out the value of difference between the both voltage sources. So both the difference between the plus 3 minus of minus 2, that is 5 by 5 equal to 1. The voltage V is determined through R and I with reference from the circuit shown is V equal to IR I square R false, V equal to RI false. Your answer is V equal to IR. Next question. A conductor of length 100 centimeters having a diameter 0.7 centimeter is connected across 20 volt supply in a circuit and 2 amperes current flowing in the circuit. Calculate the specific resistance of the conductor. Here R is equal to rho L by A is a formula used in this value, in this problem. Here to find out the area, here the diameter is given. To find the resistance, here voltage and current is given. So first find out the resistance and area through diameter, calculate the value, and the answer is C. And next question, from the given figure calculate the resistance. Next question, this is the figure, we need to calculate the resistance, equivalent resistance. Here we have 6 2, they are in series. Others, this here 8 and 8 and 24, they are in parallel. Now both 3 are in parallel. So we need to calculate this, and the answer will be 3 ohms. So you may calculate, you know the value, 3 ohms. Calculate the heart resistance value of lamp 200 watts by 250 volts, and the answer is D, 312.5 ohms heart resistance. 2 lamps rated to 200 watt of 240 volts are connected in series. Combined set is connected across 240 volt AC supply means the total power consumed in the circuit is, answer is 100 watt. 100 watt. So, and the next, what is the current in resistance R1 resistor shown in the circuit? So we need to calculate the R1. Here given the voltage 100 volts. So in a parallel circuit voltage cannot be divided. So voltage, and here the answer is answer is calculate. Here is 300 mA. 300 mA will be divided equally to get the resistance. That is, answer is 100 mA. Here we will see the values of the ammeter I1 and the ammeter I2 to find out the resistance between the current through the R1. So here what is the formula to find out the thermal efficiency of electric heater? So electrical heater formula, and here the formula is percentage efficiency, thermal efficiency is equal to M into S T2 minus T1 by 0.24 into I square RT into 100. So this is the answer C. Thank you. That's all for today. Hello friends, welcome to Recruitment Vardi. What is the value of medium resistance based on its ohmic value? So resistance are classified on their ohmic values. So here asking the value of medium resistance. So in the previous classes also we have studied some of questions on medium resistance, and here some of the questions. So what is the value of medium resistance based on its ohmic value? Answer is C, above 1 ohm to up to 100 kilo ohms. So from 1 ohm to 100 kilometers, 100 kilo ohms, the resistance is known as medium resistance. When no current flows through the galvanometer in the Wheatstone bridge. In the figure, the bridge circuit is said to be, when the no current flows through this is the circuit is said to be, we will see the answer, balanced. When the no current is flow through the circuit, current flow through the galvanometer in Wheatstone bridge, then the bridge circuit is said to be in balanced. And two incandescent lamps of 125 volts, 40 watts and 125 volts, 100 watts are connected in series to a supply voltage of 230 volts. What happens due to these connections? So here the question is, two incandescent lamps of 125 volts, one is 40 watt and other is 100 watts are connected in series, and here asks what happens for this connection. The answer is the drop excess of voltage drop across the 40 watt lamp is higher than its rated voltage, therefore it will fuse. in which material, if the temperature increases, the resistance will decrease? The answer is carbon. Carbon is a negative temperature coefficient material. That's why. So its resistance will decrease when temperature is increased. A 12 ohm resistor connected across a 60 volt DC source. Calculate the current flows through the resistor. So problems are 60 volts and 12 ohm. So here the voltage and resistance is given. You need to calculate the current. Answer is directly, we need to say answer is B. That is 5 ampere. Next question. Calculate the equivalent resistance of the circuit shown in the figure. So see the figure here. 3 resistors are connected in parallel. Calculating the value of resistance. Here the answer is so resistance 10 ohm resistance, 5 ohm resistance, 2 ohm resistance are connected in parallel, and the answer is 1.25 ohms. So calculate once. What is the commercial unit of electrical energy? Already we have studied this. The commercial unit of is kilowatt hour. The resistance offered between two opposite faces of a meter cube or centimeter cube of the material is called as 47. What specific resistance? Two opposite faces of a meter cube. The resistance offered between two opposite faces of a meter cube or centimeter of material is called as specific resistance. Specific resistance depends on length, cross section area, and its kind of material. And all the above factors are related to. Answer is 4. The amount of current flowing through a resistance depends on. Current flowing through a resistance depends on. Current flowing through a resistance depends on applied voltage and ohmic value of the resistance. So current flow in the resistance is current flow is due to the voltage, but in the circuit it will depends on ohmic value of the resistor also. So answer is the amount of current flowing to a resistance depends on applied voltage and ohmic value of the resistor. Thanks. Welcome to Recruitment Varthi. So continuing our classes with basic electricity. So question number 50. For a constant applied voltage, the current flowing through a resistance is inversely proportional to R. It's related to R, inversely proportional to R. According to Ohm's law, the relation between resistance current and potential different voltage status is V equal to IR and I equal to V by R. Answer is A. What will be the voltage drop across the resistor of 60 ohms if the current through it is 0.1 ampere? Answer is 6 volts. So the voltage drop across a 60 ohms resistor is 6 volts when the current flow is 0.1. What will the total resistance of 3 resistance R1, R2, R3 which are connected in series as shown in the given figure. So in the given figure, so these three resistors are connected in series and the not parallel, and the answer will be 20 kilo ohms. So if the resistance of 100 ohm, 200 ohm and 300 ohm are connected in parallel, and the applied voltage V is, the current flowing through the resistors is same, whereas the voltage developed across them will be different. So in the parallel connections, the series, when they are connected in series, so same series. What will the amount of current flowing through the given circuit? Here 600 is 6 volts, and the answer will be D, 0 amps. If in the given circuit the value of R3 is double, then a given voltage source raise is answer D. All currents will be affected. The cross section area of a conductor is 20 square meters and a resistance is 4 centimeter. If its cross sectional area is double, then its new resistance will be 2 ohms. It was experimentally found by James Picot Joule that heat is produced in a current carrying conductor is directly proportional to square of the current. If a 20-watt lamp connected across a 250 volt source, then what will be the circuit current? Answer is 0.8. 20 watt, that is power, 250 volts, that is voltage. So power is equal to V into I. Calculate the answer, will get C, that is 0.8. The monthly power consumption of a 10 lamps of 100 watts each used 8 hours a day will be. The power consumption of 100-watt lamps used for 10 hours daily will be. So when 100 watts lamps used for 10 hours, so answer will be 1 unit. So in next question, in a closed loop of a DC circuit, the algebraic sum of the EMS is equal to closed loop. Answer is 0. Algebraic sum of products of the resistance and current flowing through them. Equal to algebraic sum of products of resistance and current flowing through them. So this is nothing but sum of voltage drops. And next question is, what is the value of current I5 in the circuit shown below? So here I1 3 amperes, I2 2 amperes, I3 1 ampere, I4 5 ampere. The answer will be, check now. So here I2 and I5 are incoming currents. I1, I3 and I4 are outgoing currents are 3, 4, 3 plus 1, 4 plus 5, 9. And incoming currents are only 2 plus, assume I5 as X. So 9 minus 2, that is 7 amperes. Answer is 7B. And next 60. What is next question is, what is the magnitude of the current branch OX of the given figure. So current of OX, this is also same as the above question, and the answer will be D, that is 11.5. Here is 10 incoming, 5 incoming, 6 outgoing. 10, 5, 7.5 is incoming, outgoing is only 6, and if we calculate like above, the answer will be 11.5. What will the value of current? So here this is given, and this is also same as the above problem. So I1 is 2 amperes, I2 is 15 amperes, I3 is 1 ampere, I4 is how much? I5 is 20. So I1, I5 and I3 are incoming current. I1 and I5 are incoming current, that is 20 plus 2, 22, and outgoing currents are 15, 1, that is 16. 16 minus 20, 22 minus 16. Answer is 6D. How many electrons are in the outermost orbit of the semiconductor substance? In a semiconductor substance, the electrons are 4 only. How many free electrons are in the outermost orbit of semiconductor atom? Here also only 4. The number of valent electrons of a germanium element, here 4. The number of electrons in a silicon atom, here answer is 14. How many electrons are in aluminium atom? Answer is 13. How many electrons in the outermost of silicon atom? 4. How many protons in the nucleus of copper atom? That is answer is 29B. Number of protons in silver, answer is D. How many protons in germanium? And the answer is (32). How many free electrons will move across a conductor for 1 ampere current in 1 second? This answer is, we already studied here. The answer is C, 6 by 24 into 10 power 18. That's all for today. Welcome to Recruitment Vardi. Welcome to the class of Basic Electricity. Continuing the following. So, which law states the relation between the current, voltage and resistance in a closed circuit at constant temperature? Answer is D, Ohm's law. As per Ohm's law, the circuit current is inversely proportional to resistance. The unit of resistance is ohm. 4 equal resistance are connected in series. The total resistance is 800. What would be the total? The total resistance is 800. What would be the total resistance when they are connected in parallel? Answer is B, 50 ohm. In a circuit, 20 milliampere current is flowing across a resistance at 12 volts supply. What will be the current when the voltage is increased to 24 volts? Current is 40 milliamperes. Here voltage is double, there is also current also double. The potential difference is measured by voltmeter. The SI unit of electric charge is coulomb. The unit of quantity of electricity is cooling. Electric charge and unit of electricity. Cool. What is the unit of commercial electrical power? And we have studied already. That is kilowatt hour. No. Answer is kilowatt. Electric power is this is kilowatt. Kilowatt hour is the unit of electrical energy. The formula to find the specific resistance rho, where L is length, cross sectional area A, resistance is R. R is equal to rho L by A. R equal to rho L by A. Rho equal to RA by L. Answer is P. The diameter of a metal wire of a given length is double, then its resistance is the resistance will be 1 by 4th time of the. If the diameter of a metal wire of a given length is double, diameter is double, then the resistance will be 1 by 4th. Which material is having the property of negative temperature coefficients? Answer is D, that is carbon. Which one of the following has negative temperature coefficients? And answer is C, electrolytes has negative temperature coefficients. The formula to find the temperature coefficients of resistance of a material is RT. RT is the temperature coefficient resistance equal to R naught into 1 plus alpha T. Heat generator is calculated using joules is H is equal to 0.24 I square RT calories. Answer is B. Which law states that at each junction of current, the sum of incoming currents is equal to outgoing current? That is Kirchhoff current law. Kirchhoff's current law. In an electrical network, the sum of the incoming current at each junction is equal to the sum of outgoing current. What is the name of law? And this law is already we have known just now. That is Kirchhoff current law. That is here Kirchhoff's second law. As per Kirchhoff first law, which one the expression will be correct? Kirchhoff first law will be the current law, Kirchhoff second law will be the voltage law, and here as per Kirchhoff law, which will be the correct expression? That is answer here. Incoming currents equal to outgoing incoming currents I1 and I2. So this is I1 I2. Here is answer C. I1 I2 is equal to I3 plus I4 plus I5. Navier-Stokes bridge ABCD is balanced. P is equal to 500 kilo, S is equal to find the value of Rx, and that this is the circuit, and P is 500, 5, Q is 250, and this is 12. Find the value of find the value. Answer is C, 6 ohms. Wheatstone bridge network is obtained by balanced where P equal to 100, S equal to 1/3. What is the value of Rx? That is Rx value is 1300 ohm. So here ohm. That's all for today. Thank you.